A very good morning to one and all. Um, I hope that all of you are safe at your home and due to the widespreading COVID-19 disease, as per the instructions from the government and also from the government authorities, I request you all the students to follow the instructions from the government and also at the same time it's very important to follow the instructions as it's uncertain about reopening of the college due to the widespreading COVID-19. So the Kerala Technological University as well as the All India Council for Technical Education, which also insist the importance of rely upon the online resources to learn the subject. So it is very important to see that for at least for this semester, the students are supposed to rely much on this online resources for writing the exam. There is no chance to extend the semester or university examinations, which can affect the course or the examination process, which means the exams to conduct. So I request all the students to rely upon the online resources. You may please note that almost 50 percentage, more than 50 percentage of the students, both in engineering as well as arts and sciences, the students started depending upon these online resources. They started learning the courses. And if you are a step behind or you haven't started it yet, please note that you are losing the semester. So many people are well ahead of us. So utilize the time, depend upon the online resources shared by the faculties and follow it correctly so it's highly needed. And again, as per the direction of the APJ Abdul Kalam Technological University, so we, the faculty members, are also requested to rely on the video lectures, online resources, etc. during this study period. So we also will carry out continuous evaluation, internal assessment through the available online platforms to substitute. So what we generally given in classroom as classroom instructions planned during the semester. Now I request all the students to have a nice time at your home. Means be safe. Please don't go outside. Please control yourself to get away from this disease. And let's start from the lecture here. ME220 manufacturing technology. So this is the topic which we are going to take today. We are going to familiarize with the different forging processes in continuation with our classroom lectures. Today we are going to discuss about the coining, heading and piercing. Let's look into it in detail. So actually this coining is a closed die forging process used for minting of coins, medals and jewelry. Actually this coining is a special application of closed die forging, especially the flashless forging process. So we are all familiar with this kind of terminologies. We already discussed about these terminologies in the class. You know now well that what do you mean by a closed die forging? What do you mean by a flashless forging? So this coining is a special application of closed die flashless forging process. So in this process, the fine details in the die are impressed into the top and bottom surfaces of the workpiece. In order to produce these fine details, for example, the detail on a newly minted coins, the pressure required, the pressure is required for imprinting these details on these coins. So the pressure required can be high as 5 or 6 times the strength of the material. No, not only sometimes, not only single coining operation is required. For some parts, several coining operation may be required. And very important to note that the lubricants, the lubricants cannot be applied in coining because they can become entrapped in the die cavities and prevent the full reproduction of die surface details and surface finish. So as a result, the lubricant, you cannot apply the lubricant in coining process. And again, this coining is a forging process which generally meant for making parts with letters. If you want to imprint some letters on some parts, and also numbers also can be done rapidly through this coining process. And if you look at this picture, you can see that this is actually a schematic illustration of coining process. Is shown here. You can see that there is a upper die here, there is a lower die. You can see the workpiece which is holded here, and you can see that these dies are holded using a die holder, and the fine details are printed using this coining process. The right hand side picture which shows the coins which are made using a coining process. Now let's look into another important process in forging, which is nothing but the heading. So this heading is also called upset forging. Actually, this heading is essentially an upsetting operation, usually performed on the end of a round rod or wire in order to increase the cross section. So actually it is employed for the manufacture of head of bolts, screws, nails, rivets and other fasteners. I mean bolts means the bolt heads. You can produce the bolt heads using this heading operation. This that is what is shown here. The typical products are nails, bolt heads, screws, rivets and various other fasteners. And this heading is performed as a closed die forging process. And the heading machines are called headers, which are equipped with horizontal slides. You may please note that the heading machine is called headers, which are equipped with horizontal slides. So in this process, long wires or bar stock is fed into the machines. The end is upset forged and cut into the required size. And again, you can see that the heading can be carried out cold, warm or hot working condition. The heading can be carried out in all these three conditions. And again, if you look at the next slide, in this figure on the left hand side, the heading operation to form head-on fasteners such as nails and rivets are shown. You can see the die, the blank where we are forming the head punch, you can see. And if you look at the picture schematic diagram, you can easily understand how the head is formed in the die. And again, if you look at the right hand side, the sequence of operations used to produce a typical bolt head by heading is illustrated. Now let's look into another important operation in forging, which is called the piercing. The piercing is nothing but process of indenting but not breaking through, which means the process of making a small indent or cavity on the surface of a workpiece using a punch. That's called the piercing, which means, as what I mean by not breaking through means no material is cut or removed from the workpiece, which means the process of indenting the surface of a workpiece with a punch in order to produce a cavity or an impression. So the workpiece may be confined in a die cavity as shown in the image. If you look at this diagram, you can see that the workpiece may be confined in a die cavity as shown in the image. The deformation of the workpiece will depend on how much it is constrained from flowing freely as punch descends. And a common example of piercing is the indentation of the hexagonal cavity in bolt heads. That's a common example for the piercing operation. And again, this piercing force, you know that in order to, so this piercing is a forging operation, of course, we need to understand how much force is required to create this head on the workpiece, and the piercing force which depends upon the CSA, I mean the cross-sectional area and the tip geometry of the punch. And again, the strength of the material, another important factor which depends the piercing force which depends upon, and the magnitude of friction at the sliding interfaces. So these three factors, the piercing force which depends upon. And let's uh, close this lecture. So we learned about three forging processes. The one would be the coining. It's a closed die forging process used in the minting of coins. And then we learned about the heading. It's an upsetting operation usually performed on the end of the round rod or wire in order to increase the cross section, like in order to produce the bolt head, etc. Nails, we use this process. And then we learned about the piercing, that is making an indentation on the surface of a workpiece with a punch in order to produce cavity or an impression. Thank you. So we are finishing this lecture. Uh, we will discuss about the die design features, die materials, and lubricant in the next class. Thank you. All the best.